Hi guys, this is Calc video 7-13 to be watched the 15th. There's going to be no homework to go along with it. This is going to be, we're going to do an AP problem together. And I have with me the scoring guidelines for this very problem that was on an AP exam in 2005. So we're going to do this problem together. I'm going to do it how I would do it, and then I'll show you the guidelines, that how many points I would get for what I do. And okay, so this is what's called a rate in, rate out problem, and you will see why in just a moment. So a water tank at Camp Newton holds 1,200 gallons of water at time t equals 0. All right, so we've got this. During the time interval 0 to 18, this is in hours, so 0 to 18 hours, water is pumped into the tank at a rate given by W of t. All right, so off to the side, let's write for ourselves that this is the rate in. During the same time interval, water is removed from the tank at a rate given by R of t. So this would be the rate out. And guys, if you have something that's changing and and you're given like two rates that are acting against each other, if you take the difference of those rates, that'll give you the rate of change of the amount that is changing, like the total rate of change. So this is a typical rate in, rate out problem. You have two rates that are acting against each other, and if you take their difference, that's going to give you the total rate of change of, in this case, the amount of water in the tank. So part A. Is the amount of water in the tank increasing at time t equal to 15 hours? Why or why not? So guys, I have my salmon packet with me. Okay, so I'm going to be referring to this. I'm not going to keep bringing it in front of you because that would just be kind of distracting, but I will keep referring to it. So you should have that with you as well. So, so for this part A, if I hear the words increasing, decreasing, concavity, max, min, relative max, min, I need to be thinking of derivative graphs, Susan's table, all right? And then I would flip and I would look at Susan's table and I would see that f is increasing when f prime is positive, all right? So I have to see if the derivative is positive or negative. But guys, I don't have a function for the amount of water in the tank. So I'm going to do this. I'm going to let A of t equal the amount of water in tank. So I'm introducing this new function A of t. And what I'm interested in is A prime. Okay, so A prime of t. Guys, A prime of t is the total rate of change, but I know the rate of change. I know the rate at which water is going into the tank. I know the rate at which water is coming out of the tank. So if I want the total rate of change of the water in the tank, I would just subtract them. So I'm going to go W of t minus R of t. So always rate in minus rate out, and that'll give you the total rate of change. And notice I don't do W prime or R of prime. These are already rates of change. Okay, so these are already like the derivative of something. And so I have that A prime of t is equal to 95 radical t sine squared of t over 6 minus 275 sine squared of t over 3. So this gives me the rate of change of the water in the tank. Okay, rate in minus rate out. And this comes up a lot on the AP exam. All right, and now that I have my function, I just have to see if A prime of 15 is positive or negative. So A prime of 15 equals, and then I just plug this into my calculator. So I plug this into my calculator, but I'm plugging 15 in where I see a t. And guys, I'm just going to give you the answer because I've already done this, but you should pause the video, also plug it in, and make sure you get the same thing as me, because it's actually a complicated expression to work with in your calculator. And if you don't get what I get, you'll know that you have, that there's some issue, you know, with you plugging into the calculator, that you want to try to figure out what went wrong. So it is this, and I'm going to write my units. Always write your units. Gallons per hour. Now let me answer their question. Is the amount of water in the tank increasing? And then I will say no. The amount of water, and I'm going to answer their question like exactly how they asked it. So no, the amount of water in the tank is not increasing because a prime of 15 is less than 0. Okay? So there is that. Okay, now part B. And as you're doing these things, guys, you want to be asking yourself all the time, like, what is this? What topic is this? I've done my best to list, and you have another one of these packets coming out soon, but I've done my best to list the topics that you're always going to be working with. Okay, so part B. To the nearest whole number, how many gallons of water are in the tank at time t equals 18? So if I were you, the first thing I would do is I would ask myself, okay, what are they asking for? Like in terms of the functions that I'm working with and the functions that I've come up with, or the function that I came up with above, what are they asking me for? To the nearest whole number, how many gallons of water are in the tank at time t equals 18? So I want A of 18, all right? Now, I don't know this function A, which I let be the amount of water in the tank. And you could have come up with any letter to represent it. I do know A prime. And guys, so what's the relationship between A and A prime? A prime is the derivative of A. In other words, A is the antiderivative of A prime. So I want the antiderivative of this function right here. I don't know how to get it. So if you're in it, this is a theme that you should be noticing. If you don't know the antiderivative but you need it, then you use the antiderivative with an integral formula. Okay, if you just flip your packet over, it's this one right here. If you know this, we need to know at least one output for the antiderivative. Then we can express the antiderivative as follows. All right, so I want this, so I could use the antiderivative with an integral formula. So A of t is going to be equal to A of, I need to know A of something. And right up here, at the very beginning, they gave us A of 0. So this is the amount of water in the tank at time 0. So A of 0, I'm just using this formula, plus the integral from 0, so whatever this input is goes there. 0 to the input into this function goes in the top limit of integration. And guys, from now on, I'm going to use W for the input variable because X's and T's show up so much, it's easy to like mix them up. So I'm always going to use W in here. And I'm actually getting that from Evan. Thank you, Evan. So inside is going to go A prime of W. All right, so I'm going to make this more specific. I've got, actually, let me just plug in 18 right now. So A of 18, the amount of water in the tank at time 18, equals A of 0, which was 1200, plus the integral from 0 to 18. And then in here has to go A prime of W. And A prime is rate in minus rate out. So 95 radical W sine squared W over 6 minus 275 sine squared W over 3 dW, and then I can just use math 9. Now guys, like I said before, this is like a hard function to be working with you, so I'm gonna show you what I'm plugging in. Okay, so I do 1200 plus, and then I go math 9, the integral from 0 to 18, 95 radical, I can only use x's, and then parentheses, sine, x over 6, double parentheses, square it, minus 275, parentheses, sine, x over 3, double parentheses, square it. Okay. And we get this. They want it to the nearest whole number. Okay, so that 7's going to round that 9 up. So it's going to be 1,310. All right? So A of 18, and then so we'll say 1,310 gallons. Okay, so right there. That was part B. Part C. At what time T, for this time interval, is the amount of water in the tank at an absolute minimum? Absolute max or min, I left it out of the old salmon packet. I will put it in the new one. You've got to use the candidates test. If they're asking you for an absolute max or min, they will always be asking for it on a closed interval. Okay, so show the work that leads to your conclusion. So the work that will lead to the conclusion for either an absolute max or an absolute min, you will need the candidates test. Okay, so first we got to find the critical numbers. Okay, just like a relative max or min, like where you're using the number line test or Susan's table stuff, the critical numbers, you've got to see where the derivative equals 0 or undefined, all right? So this is my derivative function. It's very complicated. I'm not even going to bother. This is a calculator section. I'm not even going to bother to work with it algebraically. I'm just going to go to my graph, and I'm going to graph the derivative function. So 95 radical x sine x over 6 squared minus, and guys, don't just watch me here, please do it along with me, or even pause the video and go ahead of me. I actually have noticed some of you like trying to go ahead of me and then just seeing if we end up at the same answer. That's a wonderful idea. I'm gonna mention that in class to everybody. Whoopsie. I needed, no, that's okay, I think. All right, squared. I messed up. Okay, so I needed sine there. Sine, and then x over 3. Double parentheses. Did I already square it? Yep, squared. Okay, and then graph, please work. Alrighty, well, first thing, guys, I'm not even on my, so I've got to fix my window. All right, and I actually would have done this right away, but I'm only caring about inputs from 0 to 18. So let's see how the graph changed from there. Okay, and this is awfully steep, all right? So steep that these lines look vertical, and I know that they're not. So let me also change my Y window. So since it's super steep and it's going up really high, I'll change the window on the Y's. I'll just go from negative 100 to 100. Okay, and I can see more now the shape of the curve. All right, and you can go even a little bit higher if you want, but time is of the essence, so I would, leave it like that. So the critical numbers that I'm looking for, it's where this graph is 0 or undefined. And by the way, guys, so maybe, okay, so this is what the candidates test is. So we have T and A, all right? I'm on this interval 0 to 18, and then the points that the values, the input values that'll be between here are going to be the critical numbers. And the critical numbers are where the derivative is 0 or undefined. So I'm going to have 2 of them. I'm going to have this number and that number. And it doesn't look like they're going to be nice whole numbers, so I'm going to have to make sure to store them. All right, so I'm going to go to second Calc 0. All right. Now, right now, I start at x value 9. 1, 2, 3, 4, 5, 6, 7. So x, I'm already like over here. Notice the y value is like really high, so I'm like way up here somewhere. So I'll do this one first, okay, because I've got to do left, pick a point left, pick a point to the left of what I'm looking for, pick a point to the right of what I'm looking for, and then hit enter a third time. All right, so let me get a little bit closer. All right, my y values start going down. So I'm like over here somewhere, I'll hit enter. And then I'm gonna keep going until my y's start to go negative. Hit enter again, and then hit enter a third time. Okay, so so this first critical point is gonna be this number here. Okay, so critical numbers, so 0 undefined for t equals 12.974825, and then I will store this, and I'll store it as b, okay, because my function I already called a. All right, so let me store that, and then I'll go find the other one. So I go back to my home screen. That was an x value, so I just hit x, and my calculator is already recognizing that x coordinate that I just got. And then I just hit down here, store, and I'll store my answer as b, and now it's stored, so I could use it later. Okay, and then I go back to my graph, and I've got to find this other point here. So again, second calc 0. Now I got to go all the way like down here. So I'm going to keep going left till my y's are getting negative. Okay, so now I have a negative y. I'll hit enter. Now I got to go to the right. Okay, and then I've got t equals 6.4948402, and I'll store that as c. So second quit, x, okay, so that my calculator recognizes that, store c. Okay, so now I could use that if I want to in the future. Okay, now, so let me put these critical numbers in here. Oh, I haven't even been referring to the scoring guideline. Oh well. I promise that I'm right. Okay, so then this is going to be 6.495. I'll just round up there. But I have it stored. So when I go to find the output, I'm going to use the stored value. Okay, and then here, but like if this ends up being an answer, guys, they only want like final answers to 3 decimal places. 975. Okay. Alrighty, so now I got to find the outputs. Now, to get the outputs, we've got to use this function that we got up here from the antiderivative with an integral formula. This is going to be such a pain to be typing in 4 times. Now, actually, we already found one of these outputs. All right, so we already found this output here. All right, so at 18, we found that this was 1,310 gallons. Now I've got to find the others. Don't bother to type this in over and over and over. If I go to my calculator and I just go up, okay, so I'm going up until I can find where I used that right there. And then if you highlight it and hit enter, it'll bring it up again. And then I just go to where the 18 was in that upper limit, and I can hit 0 and then B and C. Oh, actually, I don't even need to hit 0 because I already know at time t equals 0, I would get 1,200. Hi, Luz. I'm making a video. My sister's here, guys. I'm almost done. Okay, so that goes in. And then, so where 18 was, I'll just delete that. And I'll plug in B. Oh, there it is. Okay, so 1697 is right here. Okay, I called that one B. Okay, so that's the output for this one. All right, so, and I'll just round, I'll go like that. All right, and then I gotta type in C for the upper limit. So second enter. Oh, whoopsie. So C. Okay, 525, 242. All right, so the answer is, guys, they're asking for the absolute minimum. So what's the smallest y value? This one right here. So I'll say absolute min, and they're only asking for the time at which it occurs. At what time? Absolute min at t equals 6.495. All right, and we've showed the work that leads to our conclusion. So we are almost done, guys. We just have one more part, and it's not that bad. So part D. For t is greater than 18, no water is being pumped into the tank. Okay, so this rate in is not, we're not using this anymore. But water continues to be removed at the rate capital R of t until the tank becomes empty, so until there's 0 gallons left. Let k be the time at which the tank becomes empty. Write, but do not solve an equation involving an integral expression that can be used to find the value of k. All right, so part D. So what do I know? Let me translate the information that they gave me into the notation that I've been using. Okay, with the notation that I've been using. So at time k, there's no gallons in the tank. So I'll say A of k. What do I know? I know A of k equals 0. All right. And then I also know this function here, this used to give me A of t. But for time after 18 hours, this will no longer give me A of t. So I have to have a new A of t. All right, so for t is greater than 18, I'm still using the antiderivative with an integral formula, but I'll have A of t equals A of, do I know the starting amount? So I want the amount at time 18. Even though t is for values greater than 18, it would be the amount of water at time 18. That would be what I'm starting with, the amount of water I'm starting with on this interval. Okay, and then plus the integral from 18 to t. And then what would go in here? They are telling us that after 18 hours, there's no more rate in, there's just the rate out. So it would just be R. Okay, so there's that. And now, so I need, what do I want? Like maybe I want to write but not solve an integral equation involving an integral expression that can be used to find the value of k. Okay, so I've got to get k in here. All right, so I'm going to write that A of k is equal to A of 18. I already found, like in the candidates test, and we also found it in part B, but it's 1310. Okay, so that's what that is right there. Plus the integral from 18, so k, so this input goes up there, so to k, and then R of w. So R is 275 sine squared w over, whoopsie, 3. Okay? And then, guys, what do we know about A of k? We know that this is where the amount of water, that A of k is 0. That's what we know. So 1310 plus the integral from 18 to k, 275 sine squared w over 3 dw. Okay, and there's that. And that one is really not too bad, guys. If you, I mean, once you have recognized that, like this and this, it's not too bad to get to the final answer. Alrighty, guys, that was the last video of this unit, and I will see you soon. Bye-bye.